Hello friends, welcome back to my YouTube channel. In this video, we are going to solve numerical analysis and design paper of IIPS GAVV 4th SEM. Question 1. Write an algorithm to accomplish the tasks for polynomial p of x given in the following table. The equation is p of x is equals to a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 plus up to a1x plus a0. There is a table given. In this table there are tasks for such as evaluating the polynomial p of x, dividing a polynomial by x minus r, d px by dx, differentiation of px by dx using brute force technique, and recursive relation, which is also known as recursive approach. Algorithm for evaluating the polynomial p of x using brute force technique. Iterative approach. Initialize the sum variable s to 0 for each term of the polynomial from highest to lowest degree. In this method, there are two steps. Compute the value of the term by multiplying the coefficient with x raised to the degree of the term. And second step is add the computed value to the sum variable s. The next step is return the value of s as the value of the polynomial p of x. Algorithm for evaluating the polynomial p of x using recurrence relation recursive approach. Step 1. If the degree of the polynomial is 0, return the value of the constant term as 0. Step 2. Otherwise, compute the following value of p of x recursively by first computing the value of a polynomial of degree n minus 1 by calling the function recursively with the polynomial of degree n minus 1 as argument. B. Computing the value of the current term by multiplying the coefficient with x raised to the degree of the term. C. Adding the computed value to the polynomial of degree n minus 1. 3. Step 3. Return the value of the polynomial p of x. Algorithm for dividing polynomial p of x by x minus r. Step 1. Initialize the quotient polynomial q and remainder r to 0. Step 2. For each term of the polynomial from the highest to lowest degree, then compute the value of current term of the quotient by dividing the coefficient by x minus r. B. Add the computed value to the quotient polynomial q. C. Compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. D. Subtract the computed value from the current term of the polynomial. Option E. Add the computed value to the remainder polynomial r. Step 3. Return the quotient q and the remainder r. Algorithm for computing the derivative of polynomial p of x. Step 1. Initialize the derivative polynomial d to 0 in a decreasing order. Step 2. For each term of the polynomial from highest to lowest degree, a. Compute the value of the derivative of the current term by multiplying the coefficient with the degree of the term and subtracting 1 from the degree. B. Add the computed value to the derivative polynomial d. 3. Step 3. Return the derivative polynomial d. Question 2. Write a algorithm or flowchart of the following task and complete the table. In this table, there are some tasks which we have to perform on the data set 1 and data set 2. And I have considered data set 1 as question 1 and data set 2 as question 2. Now we have going to perform all the tasks on the data 1 and data 2. Before this, there is a note. It's important to keep track of the significant figures and round off the final answer to the appropriate number of significant figures. However, since the question does not specify the number of significant figures required, the answer above are provided without any rounding. इस क्वेश्चन में अपने को सारे राउंडिंग करके आंसर्स बताने हैं कि फ्लोर डिविजन्स के बाद कैसा होता है. पहला है सब्सट्रैक्शन. क्वेश्चन 1. n1 माइनस n2 इज इक्वल टू 0.5452 e minus 99 minus 0.5424 e minus 99 is equals to 0.0028 e 99. यदि कोई भी केस, ये किस केस के अंदर एक्सपोनेंट चेक करने पड़ेंगे अपने को, एडिशन या सब्ट्रैक्शन के में दोनों ऑपरेंट्स के लास्ट के एक्सपोनेंट चेक करने पड़ेंगे। यदि एक्सपोनेंट सेम नहीं हुए तो अपने को चेंज करना पड़ेगा क्वेश्चन में वैल्यूज़ थोड़ी, जिससे कि क्योंकि डिफरेंट होने के कारण ट्रंकेशन आ सकता है कभी कभी, और दिस एरर विल बी अंडर फ्लो। क्वेश्चन 2, n1 minus n2 is equals to 0.5452 e3 minus 0.5424 e3 is equals to 0.0023 e3. After normalization, the data will be 0.2800 e1. Multiplication. In multiplication, there is no need to check or match the exponent. Question 1, n1 into n2 is equals to 0.1111 e151 into 0.4444 e50 is equals to 0.043972484 e101. After normalization, the data and eliminates the extra value, the data will be 0.4937 e100, and this will go in error flow overflow. Question 2, n1 into n2 0.1111 e10 into 0.1234 e15 is equals to 0.01370974 e5. After normalization, the data and eliminating the extra value, the data will be 0.1370 e4. Division. Question 1, 0.9998 e1 divided by 0.1000 e minus 99 is equals to 9.99 e8 e100. After normalization, the data will be 0.9998 e101, and error will be overflow. Question 2, 0.9998 e5 divided by 0.1000 e98 is equals to 9.998 e103. After normalization, the data will be 0.9998 e104, and error will be underflow. Now let's move on to the last question, question number 3. Verify associative law and distributive law of arithmetic with fitting for mantissa digit and provide correct answer if no number is truncated. First, a plus b minus c is equals to a minus c plus b. A is equals to 0.5665 e1, b is equals to 0.5556 e1, c is equals to 0.5644 e1. Second, a b minus c is equals to a b minus ac. A is equals to 0.5555 e1, b is equals to 0.4545 e1, c is equals to 0.4535 e1. Case 1. To verify the associative law and distributive law of arithmetic with fitting for mantissa digits, we need to perform the operation on the given values and check if the results satisfy the laws. LHS is equals to 0.0076 e1, RHS is equals to 0.7656 e1, or LHS equals to 0.7600 e1, RHS equals to 0.7656 e1. A bracket में b plus c is not equals to ab plus ac, and the distributive law also does not hold for these values. Therefore, neither the associative law nor the distributive law holds for these values. Case 2. To verify the associative and distributive law of arithmetic with fitting for mantissa digit, we need to perform the operation on the given values and check if the results satisfy the law. RHS equals to 0.5550 e1, RHS is equals to 0.5500 e1. Therefore, a bracket में b minus c is not equals to ab minus ac, and the distributive law does not hold for these values. Since no law hold for these values, we cannot provide a correct answer without truncation. Thank you for watching.